All right, we are live now. So, hey folks, this is me, Vishwas Nair. I'm the host of this DevOps Champion Bill Piper show. This is a workshop series that we are conducting, and there's a lot more things coming up. If you want to reach out to us, do reach out to us at connect@buildpiper.io. You have all the freedom to join us from any corner of the world, and you don't have to worry about it. Guess what? This is still available on demand on our YouTube channel. Just go ahead, type in Ops3 Solutions or something. You still get it. But this is all our humble attempt in educating you the right way, because the leaders like Luciano or any people in this series of sessions that we are doing, it's all about honoring that right approach that they are giving, and also that education that they can really give us in order to understand what is this technology all about. And I think Luciano is one of those people that I look back at whenever I'm stuck in something Node.js. I either refer to his book or else I refer to some of his articles, which are pretty awesome. And by the way, do not miss any of the insights that we are going to share today. And let's start with the show. Thank you so much, Luciano, for being on the show. It means a lot.
Thank you so much, Vishwas, for having me. I really appreciate the invite.
Sure. Let's start with this journey of when did you start literally moving inside the microservices world? Like it's all monoliths, mainframes are still there. It's not eradicated, it's still there. Some people are still using it. So I wanted to know, how was your journey towards the microservices, and what was that all about when you heard of this word called as the microservices for the first time?
Yeah, that's a great question. Like I don't really remember that there was like a specific moment when I was like, this is all microservices from now on, because I think there is still a lot of value in monoliths. So it's more of a journey where for a company it might make sense to start with a monolith because maybe it's a small company, maybe it's not really clear what kind of product they are building, and it's much easier to just start with a monolith. Then eventually, if the company is very successful and the team grows and you need to hire more people and you need to share more responsibility, create different teams with different ownership across the different parts of the application, that's probably the moment where it makes sense to start to think about, let's make a microservice. Because I think it's fair to say that when you do microservices, there is a lot of hidden cost, because you need to think in a different way. You need to put in place a lot more tooling and structure. So that cost, of course, is something you need to keep into account. So when that cost gives you value, then it's probably worth facing that cost and setting everything up. If you are a small company building a small product that you are still trying to figure out exactly what it is, probably it's not worth it to go and just build everything as microservices, because you're just going to pay that massive price without really a return. So this is always something I want to mention, because I don't want to say that microservices are the solution to all problems. That's probably not true. I think it's fair to realize when you need microservices and go for them, and when you don't need them, probably you're going to be better off with something simpler like a monolith. I don't know if that
Sure, I
makes
think.
sense to you, if you agree with this
Yeah,
perspective.
yeah. I just wanted to know one thing. Like, we are going to start with a lot of sessions. There's a demo coming up. There's slides, of course. You can see it right away. There's a slide and everything. But I wanted to know, like, how was that journey of starting up with Node.js? Because fundamentally, Node.js is also there are a lot of issues faced by some of our customers. Some of our people still face a lot of chaos while really optimizing something using Node.js. So I just wanted to know, what is that first learning that every microservice builders using this Node.js as the backend need to know before they hop in with the Node.js as one of the backend technologies?
Yeah, that's a great question. I think it fits nicely with the topic of the presentation we are going to be discussing later. But basically, I can tell you about my experience. Like when I discovered Node.js, I was for a long time a PHP developer, but I was trying to be as full stack as possible, because I always enjoyed kind of building things end to end and seeing how can I build a feature from the front end to the back end to the database and release it as well, trying to understand the full process. So what I was effectively doing was a lot of PHP on the back end and a lot of JavaScript in the front end. And I was always struggling to keep some level of consistency. For instance, the common example is, how do you do validation? You have a web form, you want to have some client-side validation of that web form. But then, of course, when the data is submitted, you need to do the same validation on the backend to be sure that the data is consistent, because, of course, you cannot just trust the client validation. So that meant that I was building the same validation code both in JavaScript and PHP, and there was a lot of code duplication. It wasn't always exactly 100% the same. So when I discovered Node.js, I was like, oh, I can finally use JavaScript for like everything from that backend. And probably that means I can start to share a lot of code between the two parts. So that was for me the trigger where I felt like, okay, I want to invest in this technology. I want to learn it. I want to master it because I see a lot of potential there. And I think that time proved me right, meaning that Node.js has been like growing a lot and has been adopted by a lot of companies in a lot of industries. You are right in saying that there are still some rough edges, like it's still JavaScript, and JavaScript looks like a simple language, but in reality, it's not. Like you really need to learn it and master a bunch of different topics to be able to write production-ready code. So I think the presentation today can help a little bit, because my feeling is that the most difficult part of learning JavaScript and Node.js is understanding all that asynchronous journey, especially if you're coming from a language like, I don't know, Java, or maybe old style Python where you never used async await. Going into JavaScript, it might be very confusing at first. You might do a lot of mistakes just because you don't fully understand the asynchronous model. So today we're gonna try to cover kind of a journey from callbacks to async await, and all the different nuances that you need to know, and why there is this journey from callbacks to async await, and all the different things that are built on top of each other. And then we're going to discuss some patterns that you can use commonly, for instance, when you need to do asynchronous iteration, when you need to do multiple things concurrently. And hopefully that's going to help people to get started with Node.js and feel more comfortable that are not going to be doing the same mistakes that everyone does while they are learning all the journey from zero to production ready.
Sure, let's just start the session. I know everybody's pinging me and saying me, you know what, Vishwas, just start the session as soon as possible. I'm like, let's start it. So here's the screen, and I'll be moving out. So the stage is yours, Luciano. Thank you so much.
Thank you so much, Vishwas. And thank you everyone for being here. So I just want to start with very quick introduction about myself. So my name is Luciano. I am originally from Italy. I am a Microsoft MVP, solution architect certified with AWS, and I've been recently nominated AWS Serverless Hero, which is something totally unexpected but made me incredibly proud. I work as a senior architect at a company called Fortiorem. I live in Dublin, but Fortiorem is like a fully remote company. I'll give you some more details in a second. And one of the things that you might know me for is being the co-author of this book, Node.js Design Patterns. If you haven't read the book, it kind of goes pretty much in line with some of the topics we are going to be covering today. And the whole goal of the book is to try to help people that have some kind of familiarity with JavaScript to kind of ramp up and do the next step, making sure that they learn what needs to be done to build production-ready applications. So make sure to check it out if you haven't done it already, and let me know what you think. If you want to connect with me, you can find me in a bunch of different places. I'm generally very active on Twitter, so don't hesitate to reach out. I'm generally happy to talk with people and discuss, especially if you want to talk about Node.js, JavaScript, definitely feel free to ping me and let's connect. Okay, about Fortiorem, we are a service company. We are very focused on cloud computing, especially AWS and serverless. We are AWS partners, and we do a lot of things to kind of promote cloud computing and to evangelize what we think is kind of the future, building more and more applications in the cloud. And just to give you a proof of that, we have a weekly podcast, myself and Owen Shanahy, who is the CTO of Fortiorem, where we discuss all things AWS. We try to answer all sorts of different questions. And just today, we release a new episode that is all about managing cost on AWS. So if you're interested in this kind of topic, AWS Cloud, feel free to check out AWS Bytes and let us know what you think. Okay, back to the presentation. So I already mentioned in the introduction that I think one of the most complicated things in JavaScript is asynchronous. And asynchronous is very tricky. And if you have explored a little bit of JavaScript already, you probably have seen callbacks, promises, async await, streams, event emitters, async generators, promisify, promise all settled, all these kind of topics, and they can be very overwhelming and confusing. And especially if you haven't seen all the history of JavaScript, I think I was lucky enough to start to learn JavaScript when the only tool was callbacks, and then see all the progression. Everything kind of made more sense in a progressive way. But if you're starting today, it might be very overwhelming and confusing, because you need to figure out even how to put different things in order, what comes first, and why so many different concepts exist. So today I'm going to try to demystify all this history and try to give you all the building blocks that you need to really understand async await. And I think once you have done that, you have done already 50% of the difficult parts of JavaScript. So hopefully today is going to give you, after today, you're going to have a lot more confidence that you can write production ready JavaScript. So the agenda today is to discuss what async even is, then callbacks, then promises, async await, some common async patterns. So what you are going to find most of the days in your daily work dealing with JavaScript, what kind of problems can you solve, and what kind of patterns are going to help you to solve these kind of problems. And then we're going to discuss some other common things that still happen a lot. Like, for instance, what happens when you want to use async await, but you have an API that gives you callbacks, and vice versa? How do you manage those situations where you want to use a particular style of async, but you have to deal with other styles just because you are using different libraries or different frameworks that don't always support the style you want to use? And finally, I'm going to try to close this talk with a performance trick, which is something very, very specific. It might not always apply to your use case, but it's something that I think it really highlights how important it is to understand the whole async history in JavaScript. Because if you do that, then there are a lot of opportunities for optimization or for restructuring your code that opens up for you. So it's going to be an example, very practical. Maybe you won't need it, but hopefully highlights how important it is to understand async in JavaScript. Okay, so what does async even mean? So in JavaScript and Node.js, all the input and output operations are said to be non-blocking. And the classic example of that is, for instance, you are reading the content of a file, or you are making an HTTP request, or you are loading some data from a database. All these operations are I/O, input-output operations, and those operations are unblocking in JavaScript and Node.js. But what does that mean in practice? And I think a good way to try to visualize that is to make an example and compare a blocking style language, for instance, Java and JavaScript, and do something quite simple, at the same time quite common, and see how the runtime behaves in these two different styles, the blocking style and JavaScript non-blocking style. And the idea is that we want to do three things. We assign a variable. For instance, we can say x equal 1. Then we read some data from a file. And finally, we print something to the standard output. And we can do the same thing in pretty much any language, but we are trying to imagine what happens when we do that in a blocking style language like Java and in a non-blocking style language like JavaScript. So if we start to execute some imaginary code, here I'm not even giving you the code, what happens is that the first step is synchronous in both languages, in both environments. So that operation happens, and while that operation is happening, nothing else is running on that particular process. Then we start to read the file. And this is where things start to get interesting, because in a blocking style language, what is going to happen is that our process is going to start to interact with the operative system, is going to do a bunch of system calls, and is going to start to read the content of the file. And while all of that is happening, nothing else is happening. Like, the program doesn't do any progress to the next instruction. While if we look at JavaScript, something different happens. So if we step forward, we can see that this I/O operation is initiated in both places. But the next step is that while that operation is blocking on the left side, and nothing else is happening, in JavaScript, what happens is that basically we schedule that asynchronous operation, and then the program continues. So we immediately print something to standard output, while in the blocking style, we are blocked and waiting for that IO operation to complete. So at some point, this IO operation finishes. In JavaScript, at that point, we are already done because we already progressed to the next instruction and then to the end. While in the blocking style language, at that point, we got unblocked, so we can finally print to standard output, and then we can finish the execution. So you can already see that there is an obvious difference. Every time we are doing something that involves IO, in the blocking style language, we stop there and we wait for that operation to complete. While in JavaScript, that particular IO operation is, let's say for now, is just scheduled on the background. It's somehow managed by the runtime, but the code will immediately continue to the next instruction. So non-blocking IO is convenient. There is a reason why it exists, and the reason is that you can do work while the operative system is taking care of managing that IO operation for you. If you're reading a file, the operative system is doing most of the work, so our process, meanwhile, can do something else. But the problem is that generally, when you are dealing with IO, you want to know when that IO operation completes, right? It's true that it's okay to schedule it in the background and let it go and meanwhile do something else. But eventually, we want to know when that operation is completed, and probably we want to do something useful with the data. Otherwise, probably we wouldn't even need to initiate an IO operation. So what do we do then? Like, what is the way that allows us to interact with this scheduled operation and know exactly what's going on? Is it complete? Did it fail? We need to know it, and we need to react to that kind of information. And the first thing that we had was callbacks. And callbacks are the most primitive way that allows us to interact with IO operation and know when they either finish or they fail. So let's see how callbacks work. So generally, when you're doing something async, when you are calling some non-blocking code, you have a function, you can pass multiple arguments to these functions, and the last argument is generally a function that is called callback. And generally, you would use it like this. You will say, okay, I'm going to call this function, I'm going to pass argument 1, argument 2, and then I'm going to specify a callback as an inline anonymous function. And in this callback is where I'm going to be writing what is the business logic that I want to perform when this asynchronous operation either completes or fails. And failure is actually very important, because most often this is one of the big mistakes that people do, that they forget to handle possible errors, especially in callbacks. So always remember that an asynchronous operation can fail. Therefore, you always need to add this kind of snippet of code at the beginning, making sure that if there is an error, you are doing something to handle that particular error. If there isn't an error, you have your business logic after that. So let's actually see a bit of a more practical example, because everything is in abstract right now, so it might not be the easiest to understand. Hopefully, with an example, we can clarify all these concepts. And the idea is that, for instance, we are building a booking application for an hotel, right? And we might want to build a specific piece of functionality where we want to fetch the latest booking for a given user. If that user actually has a booking, the latest booking, we want to print it in the terminal. So how do we implement all of that? And you have to imagine that to fetch the latest booking, we are probably calling an API or connecting to a database. So that's going to be an asynchronous operation. Okay, let's imagine that we have this particular function called getLatestBooking. How does this function work? It's something that somebody else implemented. Here we are just calling it, so we are just using this function. And we are assuming it's an asynchronous function, so it uses callbacks to kind of give us a way to interact with the operation. So what we need to pass is the user ID and then a callback. So this is the callback we are actually passing to basically react to the asynchronous operation, when either the operation fails or when we manage to get a result. In this case, it's going to be a booking. So what do we need to do? First of all, always do error handling. So if this thing failed, we are just going to print the error in this particular case, but we are handling the error. We are not just ignoring it. Then we need to check something else, like this is our business logic. We are assuming that a user might have or might not have a booking. So booking is not necessarily a value. We need to check, do we actually got a booking? If we did get a booking, then we can just say we found this booking for this user and this is the object. Otherwise, we can just say this user doesn't have any booking. So this is kind of shows the idea that we call an asynchronous function, we pass all the arguments we need to pass. The last argument is going to be a callback. This callback is a function that gets executed when the asynchronous operation either completes or fails. So always remember to handle failure first, and then you can describe your business logic. What do you actually want to do with the data? Now let's see a slightly more realistic example. It's very similar, but we are adding a few more steps to make it more obvious to see all the complexity that gets created when you have to deal with more realistic scenarios. And for instance, here we still want to get the latest booking for a given user, but if that booking exists, we want to cancel it. And if the user already paid for it, we want to refund that user the amount of money that they already paid. So you can imagine how this is a much more realistic use case. Like you might want to have that feature in a booking platform for an hotel. And you can start to imagine that given that there are many steps and every step might be asynchronous, that we will need to deal with much more complicated code, and we need to coordinate all these asynchronous operations and make sure that they happen in the right order. So how do we do all of that with callbacks? And you can see that we already have 30 lines of code. So this is getting already much more complicated. But let's try to have a quick look at it. So it's the same function, get latest booking, until pretty much line 9. The only difference is that in line 9, when we have a booking, now we can check, we can actually cancel it. And then when we cancel it, we can check if it was paid. At that point, we refund the user. So imagine that we have all these functions coming from a library, get latest booking, cancel booking, refund user. Here we are just creating a workflow that coordinates all these asynchronous functions. And you can see that here there are a few problems. The first problem is that we are repeating the error handling code 3 times. So every time we have a callback, we need to repeat this error handling code, which is a little bit annoying, and it creates a lot of boilerplate that we need to kind of copy paste from one place to another, and it's just room for mistakes, right? And that's one problem. The other problem is that we have nested callbacks. So every time we have a callback inside a callback, you can see that the code moves always a little bit to the right. And there are some common jokes that people would refer to when they talk about this in JavaScript. One is the pyramid of doom, because this code looks like a little bit like a triangle. Sometimes it's also called callback L. And sometimes you also see this funny meme of like there is a Street Fighter Hadouken that is pushing all your code to the right. And this is just to highlight that this is not nice code. Like this should be written in a better way. This is going to be very hard to read and to maintain, and it's very error prone. So we can do some things. We can maybe refactor this code a little bit, and that can help. And I'm going to show you a few quick tips. But later on, we will see that there are even better ways to handle this particular type of business logic and get code that is actually easier to read, easier to write, and easier to evolve. So what can we do if we just want to stick to callbacks and make our code a little bit more readable? So here we are defining our own new utility function, which is called cancel and refund booking. So we're kind of extrapolating some of that business logic we saw before and moving it into a dedicated function. And here we still need to deal with errors, of course, because again, it's a callback-based function that is doing asynchronous stuff. And there is still a little bit of duplication, but this time we only have 2 places where there is duplication of error handling and not 3. And Here we also need to propagate possible errors or success, because basically this is an helper function. So we don't really know what the user wants to do. We need to accept a generic callback, and then we need to invoke that callback either when there is an error or when the operation is completed successfully, which are the two cases we see here. And another thing that is important to note is that here we inverted the check. Before we were checking if the booking was paid, do something. Here what we are doing, we are saying if the booking was not paid, then we can return straight away. This is a technique that's sometimes called early returns. And it, when doing asynchronous code with callbacks, is generally a good technique because it helps to reduce the amount of nesting. Because you can just say return and you don't need to create another if block that contains a lot of code inside that can get more and more nested. So this is another refactoring trick that you might use to try to reduce the complexity of asynchronous code. So how do we use this particular function? We can just call it, we pass a user ID, and then we pass our callback. And in our callback, now we just basically have a much simpler logic. We just need to check if there were errors, and then we can just console log and say the booking was canceled and this amount of money was refunded. You can see that this is a little bit nicer, but still there is some code duplication. We still are managing errors in a bunch of different places, so it could be better, right? And this is why we have promises. Promises were the first attempt to try to make callback-based call a little bit simpler to reason about, a little bit simpler to write and read and evolve. So let's see what is effectively a promise. And what is the problem that we have with callbacks that promises try to address? And the problem is that when you write callbacks, you are not in charge. You are basically trusting whoever implemented that callback-based function that when the work is done, they will call you back and invoke the function that you are providing, which is good. I mean, most of the libraries are reliable. We can trust them. But at the same time, creates an interesting model where you just pass functions around and then you need to wait for these functions to be invoked. And promises try to invert that model a little bit. In practice, behind the scenes, it is still based on callbacks, so take that with a pinch of salt. But from a user perspective, promises feels like they give you a lot more control, because what they do is basically they say, you can call an asynchronous function, you are going to get back an object, this promise object, and this promise object is something that you control in your code, in your business logic, and it can be used to tell you what's going on with that asynchronous operation. And a promise object is a stateful object, and it can have two possible states. It can either be pending. For some reason, the animation is not in line. Don't worry. So a promise object can either be pending, which means that asynchronous operation is still in progress, or it can be settled, which means the operation is completed. And when a promise is settled, there can be two possible outcomes. Either it's fulfilled with a value, which means, okay, we did all that asynchronous operation, we completed it successfully, and we have a value. We fetched the value that we wanted to fetch. Or it can be rejected, which means there was an error. We were not able to fetch the value, so the only thing we got is an error. So you can use this error to decide what to do next. So how do we use this particular promise object? How do we know when that particular promise object changes its state? Because initially it's always going to be pending, and eventually is going to be changing state. It's going to be either fulfilled or rejected. So how do we know when it is fulfilled, and how do we react to that? We can use this promise object.then, where we pass a callback. So again, it's still a little bit callback based. We have a little bit more control, but we still need to understand callbacks. And in this particular callback, though, we don't have to worry too much about errors, because this callback gets invoked only when the promise is fulfilled, which means we managed to get the data successfully. So it's a slightly simpler way of thinking about what's going on with that promise object. But we still cannot ignore errors, right? Because errors still might happen. So how do we handle possible errors? we can again say promise object dot catch, and this is another separate case where we say, okay, if there is an error, call this other function, and in this other function we take care of managing errors. Now, this is useful, but this is only part of the story. The real power of promises is based on the fact that you can actually chain all these different things, and you can create asynchronous pipelines. So you can define, if you have, for instance, multiple steps that rely one on the other. So, for instance, you want to do something, then if you get a result, you want to do something else. Then if you get another result, you want to do another step. And then the cool thing is that basically if there is an error, you can define a single catch at the end, and that catch will capture any error at any stage of this particular pipeline. So this is where promises are useful, because you can easily chain multiple steps, and then you can have a single place where you handle all the errors. And there is another thing that you can do. For instance, if you just want to know at the end of this pipeline, either it failed or it succeeded, you want to do something else, for instance, close the connection to the database, you can also use this dot finally to execute some cleanup code that gets executed regardless if the promise was successful or it failed. So how can we create our own promises now? Because so far we only saw how to use a promise. So if a function is returning a promise, how do we interact with that promise? But sometimes we want to create our own functions that will return promises, because maybe we are building a library of exposing some kind of asynchronous functionality. And the easiest way to create a promise is to use this constructor, new promise, and then you need to pass a function inside. And this is sometimes called the executor function, and it's the function that defines what is the behavior of this promise. What is this promise doing behind the scene to fetch some data from somewhere or perform some kind of I/O asynchronous operation. Now, the interesting detail that is worth remembering, and this is different in some other languages that use async await, is that in JavaScript, executor functions for promises are executed immediately. So when we initialize the promise, this function is called immediately. And what are we supposed to do with this executor function? Again, we define the business logic of that promise. So we want to do something asynchronous, and we have two arguments that will get passed into this function. One is called resolve, and another one is called reject. And those are basically functions that we can call to indicate that we want to transition the state of this promise. So for instance, we do something asynchronous. If there is an error, we can call reject with that error. If we complete successfully our asynchronous operation, we can call resolve with that particular value, so that the value is propagated outside the promise. There are also some shortcuts, like sometimes you just want to create a promise that is already resolved with some value. Sometimes you want to create a promise that is already rejected with some error. So you can just use these two helper functions here. Now let's see a slightly more practical example. For instance, we want to create a database library, let's say, and in this database library, we want to expose a function that is called queryDB, which allows us to receive a client, so a connection to the database, and a query, probably as a SQL statement, so a string that contains some SQL code. And we want to return a promise that kind of represents that asynchronous operation. So on the other side, users can just call this function, they will receive a promise, and then they can use this promise object to see, was it succeeding? What is the result? Did it fail? What is the error? So basically what we can do here is we create a new promise. We have this resolve and reject that define the arguments of our executor function. Then we are going to be calling some asynchronous action. Here I am imagining that we have this client.execute query. And this is actually a callback-based function. So we pass a callback. And inside this callback, if there is an error, we can call reject. If there isn't an error, we can assume we got the data, so everything is successful. So we can call resolve with that data to propagate that information. So here I'm kind of already showing you one of the patterns that we will discuss a little bit better later, which is promisifying callback-based functions. So basically, we have this client execute query, which is a callback based library because it accepts a callback, but we are wrapping it into a promise so that whoever is calling this high level query DB function can deal with promises, which are a little bit nicer to deal with rather than dealing with callbacks. I hope that all of that makes sense, but if it doesn't, feel free to ask me questions later if we have time for a Q&A or after on Twitter or on LinkedIn. So there is another example. How do we actually use this query DB functionality that we just created? We just call it. We know that this function is going to return a promise. So basically, we can call .then straight away and do something with the data. We also know that a promise can fail. Maybe the database connection cannot be established. So we need to handle potential errors and say, sorry, we were not able to run this particular query, and this was the error. And also, we can add a finally block where we can say, okay, whatever happens at the end, I just want to disconnect if that client was still connected to the database. Okay, now let's think again about our booking example. So we want to fetch a booking for a given user. If that booking exists, we want to cancel it. If the user already paid for it, we want to refund the user. But this time we want to make an effort to try to think what happens if we have libraries that give us promises rather than callbacks. How does our code change? And you can already see that before we had like 30 lines, here we have 22. So at least we are making our code a little bit shorter. So this is definitely a win. But yeah, how does it look like? We need to call get latest booking. And you can also see that there is no pyramid of doom straight away. Then we do the first step. So when we get the latest booking, if we have a booking, we can say, okay, we found a booking and we can return cancel booking. This is important. We'll talk a little bit more about this in a second. But the basic idea is that from a then block, if you return a promise, because cancel booking is going to return a new promise, then that promise is propagated to the next then block here. So basically from one then block to the other, we can just return promises and create a chain of operation. And this chain is linear, like it doesn't go nesting more and more because you can call the .then in line with the previous .then. So here, basically, we are saying if we get here, that basically means that we call cancel booking in the previous step. And therefore, what we can do is check if that booking that we just canceled was paid for. In that case, we call refund user in line 12. And again, we are calling another function that returns a promise, so we can do another .then step. And here, what we just need to do is, okay, if we was refunded, we just need to say the user was refunded. Finally, we have a catch block, which is going to be able to capture errors at any stage of our code. So again, you can see that there is no pyramid of doom. There is less noise because we are not repeating the error checking over and over. And we were able to propagate multiple asynchronous steps in a way that is a little bit more readable because it looks a little bit more sequential and it's not just functions nested inside other functions, nested inside other functions. Now, one thing I want to mention before we move on is that this code is still not perfect because, for instance, we have to do all these if statements in line 3, in line 10, in line 16, just to check what did it really happen in the previous step? Did we get a refund? Or maybe we didn't even get here. So you need to be still a little bit more careful, especially when you have conditional logic or if you have something that needs to be repeated multiple times. Promises are still not perfect. They still require you to do a little bit of boilerplate, which sometimes can be a little bit confusing. And that's why we have async await, which also tries to build on top of promises, which they also build on top of callbacks, and try to give you an even better experience. So you can see how we started from callbacks, we explored promises, and now the next step is to see what is async await giving us that makes our life easier when doing async or non-blocking programming code with JavaScript. So the idea is the following. Sometimes we just call a function that returns a promise. but we just want to wait until that promise is completed. For instance, we are writing our code. We know that JavaScript is non-blocking. If we do something asynchronous, it's just going to go to the next line. But sometimes we just want to tell JavaScript, wait, don't go to the next line until this particular asynchronous operation is finished, because I don't have anything else to do until I actually get this data. And this is actually very common in many cases. Like, it's very good that JavaScript gives you the opportunity to do things in the background and continue with your progress, but sometimes you just cannot do any progress until that data is available. So await allows us to express this particular concept. We have a promise doing something asynchronous. We are not going to be able to do anything until that promise completes. So we are just going to wait that promise and block the code there. Now, when I say block, this is not really blocking. Behind the scenes, you could have multiple promises doing things in multiple places at the same time. So it's still a concurrent model. So take that with a pinch of salt. But if you're focusing on one particular function, the mental model that you can build is that this particular function, when it's executing, is not going to progress until that particular promise object is either fulfilled or rejected. And of course, we can also write this in line. We don't have to assign the promise and then await that promise. And the other cool thing about await is that if that promise is fulfilled, it will automatically evaluate to the data that is being returned by the promise. So this is just a nice way to extrapolate data from an asynchronous operation. We can just say const data equal await some particular promise. So this is a very common way of writing async code. If you have used something like fetch, generally you will see something like const response equal await fetch some particular HTTP URL. But how do we handle errors? And the cool thing about await is that if there is an error, it just raises an exception. And this is actually very cool, because that means that we can just wrap all our business logic in a try-catch, and that try-catch will be able to capture both errors that are synchronous, which will raise exceptions, and errors that are coming from promises that are actually rejecting. So this is another huge advantage that you get by using async await, that you don't have to think, okay, what about synchronous errors? I need to use a try-catch to get all these errors. What about asynchronous errors? I need to either do a catch block in a promise, or I need to make sure I always do if error in callbacks. And your code gets very, very messy, and you end up with error handling logic that is scattered all around in different ways. And if you forget to handle some of these errors, sometimes you have no visibility that those errors are even happening, and your code might start to perform badly in different ways. So with async await, you just write a try catch, and that will be able to capture everything. Now I'm going to speed up a little bit because I realize we are running out of time, and I have a few more topics that I want to cover. But basically, an async function looks like this. So async await is kind of a two-story part. Await allows you to block on promises, while async is a keyword that allows you to define functions where their behavior is intrinsically asynchronous. What does that mean is that you can write an async keyword before the function keyword, and then inside this function, you can return some value. But what's happening behind the scene is that this function is literally equivalent to this other one we can see at the bottom, where effectively it's like we are saying, when we say async function, we are saying this function is going to return a promise, and that promise resolves to the value that we have when we have a return statement in that function. So you can see that if we want to convert an async functions to plain JavaScript with promises, you just need to return a promise that resolves to the value that we wanted to just return in the first place in the asynchronous function. And similarly with errors, so if you have an async function that just throws an error, it's like returning a promise that just rejects with that particular error. So again, asynchronous functions are not magic. They are just built on top of promises. You can see them as syntactic sugar for promises. Now, the cool thing is that when you define an async function, you can use await inside that async function. And basically, this is the nice way that you can combine multiple asynchronous steps. So for instance, in this function, you can say, do something, get the data, do something else with that data, get more data, do something else with the final data. And you can keep going and do as many steps as you want. And the best part, and this is what to me solves all the previous problems that we discussed before, is that it's also very easy if you want to have conditional logic or if you want to have loops, you can do it in a way that looks synchronous because you are writing code that is very imperative and very easy to read and reason about. But at the same time, you can mix a wait inside of that code to stop whenever you need to fetch more data to be able to progress. So for instance, here in the await that you see here, what we are doing is at every iteration of the loop, we stop until the record is updated. Then when this particular record is updated, we resume the loop and we keep going. So this is actually very useful in practice. Now, very quickly, if we want to see that example that we discussed before, so we want to cancel a booking. So how do we do it with async? Very easy. We get the latest booking. We just do await, get latest booking. We will have the booking in a variable. Now, we know that booking might also be empty if the user doesn't have any booking. So if it's not there, we just console log it's not there. Then if it's there, we just say we found a booking. Now let's cancel it. So we just call await cancel booking. And if this operation, when this operation completes, we can assume, okay, the booking was canceled. And now we can check, wait, was this booking paid for? Because if it was paid, we also want to refund the user. So we can, again, just call await refund user, and that's pretty much it. And you can see how this code is much more readable, like it reads very sequentially. The only thing we need to be careful is that every time we are calling an asynchronous operation, we need to make sure we put a wait to stop there and wait for the data to arrive before we continue with the next instruction. Now, just to make a very quick summary, async await is great, helps a lot to keep the code simple and readable. But to use async await, you need to understand promises, because we saw that async await is heavily built on promises. It's just an abstraction built on top of promises. So if you don't understand promises, you are going to be doing mistakes. So make sure you understand promises. And the problem is that to understand promises, you need to understand callbacks, because in turn, promises are built on top of callbacks. So really, you need to do all the journey. You need to learn callbacks, then promises, then async await. If you skip any of the steps, then your understanding of JavaScript is not going to be perfect, and you are going to be doing mistakes here and there, and you are not going to be trusting too much your code. So I know it's painful to use callbacks. I know it's painful to use promises, and it's just nicer to use async await. But I assure you that if you start and make an effort to learn callbacks, then you move to promises, then you move to async await, at the end of the day, you are going to be thankful because you understand exactly what's going on and you can be very flexible. Okay, now I'm going to do a very quick run through some of the most common asynchronous patterns. And sorry if this is going to be a little bit quick, but I want to make sure we cover everything before we run out of time. So there are some things that are very common. For instance, you want to do sequential execution. You have a number of items and you want to do something asynchronous for every single item. And the easiest way to do that is you have an array of things and you do a regular for off loop. And that for off loop basically is giving you every user ID in this particular example. So inside our loop, we can do something for every single user. And in this case, we are just using a wait inside the for loop to say, don't go to the next item until this particular item is canceled. So this is how you can do sequential execution. You have a bunch of asynchronous steps to do, but you want to do them in order one after the other and not concurrently. Now, sometimes people use array.map, and this doesn't really work as expected, because when you call array.map or array.forEach, these functions, these array helper functions like map and for each, they don't understand async. So what they will do, they will just spawn your callbacks multiple times in sequence without waiting for that promise to be completed. So if you write this code, this is actually a very common mistake. People think that this is going to be sequential, but actually this is going to be concurrent, just because for each and map, they will not make anything special when you have an async function inside. Okay, then another case is what if you actually want to do things concurrently? One pattern is to use this function promise.all, which basically what it does is saying, okay, I have these 4 items here for users. I want to cancel all the bookings, but together in a concurrent way. I don't want to block on the first one, then the second one, then the third one, then the fourth one. Of course, they don't have any correlation with each other, so why not going faster and doing everything concurrently? And one way to do that is promise all. And the way promise all works is basically an helper function that takes an array of promises that here we are building with user.map. And it basically reject. So it gives you back another promise, which represents all these things happening concurrently. And this promise rejects if there is an error and resolves if everything goes well. Okay. So this is a little bit of a problem. Like, this is very common to see promise all, but the problem with promise all is that if there is an error, you don't really know exactly what happened because you only see that error. You don't see if there were other errors, what succeeded and what failed. So it's very hard to react to errors and decide, should I retry something? Was there something that succeeded? Was there something that failed? It's just very hard to see exactly what happened when there is an error. So in practice, it's much better to use this other function called promise all settled, because promise all settled returns something like this. So it's still a promise, but this promise is resolved to an array of results. And for every result, you can see, was this particular operation successful or failed? And if it was successful, you will see the value. If it failed, you will see the error. So in practice, my suggestion here is to always use all settled rather than promise.all. Now, I have another couple of examples, which I'm going to go very quick through them. We already saw this one. What happens if you have a callback-based function, but you want to use async await? And if you're using Node.js, actually Node.js in the last few years has evolved a lot. And for most of the callback-based functions, there are already equivalent promise-based functions that you can find already in Node.js. So the only thing you need to do is to import different variations of those functions. For instance, file system here. If you import this file system, every function, for instance, read file, is callback-based. But if you import read file from fs/promises, that read file is going to be promise-based. So you can use async await straight away with this particular version of the library. I know it's a little bit annoying that you need to check, is this callback based, is this promise based, and which one do I need to import? But it's also great that Node.js itself is moving into supporting more and more of promise-based functionality, and that means supporting first-class support for async await. And when that's not available, for instance, one example is the zlib library, which is built in Node.js and it's callback based, but that library doesn't expose a promiseified version of that particular functionality. So what do? We can promiseify ourselves. And there is a utility function you can use in Node.js, util.promiseify, that if you pass a callback based function, it returns the same version of that function, but that function now uses promises rather than callbacks. It might seem a little bit magic, but the final point is that you don't need, after you promiseify this gzip function, we get back gzip promise. And when we call gzip promise, that's going to give us a promise rather than having to use a callback. So we can just use await with this particular function. There are also ways to promiseify things yourself. This is, for instance, more useful when you're doing that in the browser and you don't have the util promiseify that Node.js gives you. And it's not very complicated, and it's very similar to the code we saw before in one of the previous examples. So I'm going to skip over this one. Now, it is also possible to do the opposite. For instance, you have a promise-based library, but you want to use callbacks. It's a bit of a convoluted example, so I'm not going to give you too much detail, but just be aware that there is the opposite. Like if we have promiseify from callback to promises, we also have callbackify, which takes a promise-based API and converts it to a callback-based API. So if you ever need to do something like that, you can use this particular library. Now, just as a final thing, this is the last part of my presentation. you might wonder, is this stuff really worth it? And I kind of already said that it is, because if you want to write production code JavaScript, you need to really understand the asynchronous model and all the primitives that you can use with the asynchronous model. But here I want to give you a little bit of a more practical example. And the idea is that when you understand the asynchronous model, then you can do things that can also help you to get more performant JavaScript. And this is a very specific example, and it's called the request batching pattern. The idea is the following. We have a web server, very classic thing, web server using a database. So every time a user is doing a request, we probably want to interact with the database in order to fulfill that particular request. For instance, let's say that this user is trying to search for hotels in Rome. They're going to call this particular API. This API, there is an HTTP layer that needs to connect to a database to get the data and send it back to the user. Very common thing. Now, what happens if there are multiple users, right? We are being very successful with this project. Lots of users want to use our application. It might actually happen that in a very short amount of time, 3 users are actually looking for the same thing, searching for hotels in Rome. So what happens is that our web server is receiving 3 requests, which are effectively the same. It's creating 3 different queries to the database, but the queries are actually trying to fetch the same data just to return the same response to every user. So you can already see that there is a lot of waste here, because, I mean, we are doing the same request. We could do just one query to the database and return the same response to the 3 users as soon as that query is completed, rather than doing 3 different queries and overloading the database. And now with 3 queries, it's not really a problem, but you can imagine that if you have thousands and thousands of users, how much more expensive this approach becomes, rather than trying to optimize there wherever we see the same request. Now, one simple way that we can fix this problem is to just put a caching layer in front, but here I'm showing a slightly different approach. Okay, what is the idea? The idea of this pattern is that we can kind of keep a book of all the requests that are in flight. So basically, when the first user issues this request, while we are loading this, we actually do the query to the database because it's the first time we are seeing this request, but we are also recording that this particular request is in progress. So what happens when a second user does the same request while the first one is still in progress? Or a third user does that, or n users do the same. At this point, we know that that request is in flight, so we are not going to initialize new requests. We are just going to wait for that query to return. And that query returns. We know that it's completed. We know that there are 3 users waiting for it. So at that point, we just funnel out the response to all the users. How do we actually write this code? Like, it looks very complicated, but actually I'm going to show you that it is not a lot of code. And actually, I'm not even using any framework, right? Here, I'm just using HTTP from Node.js standard library. So this can be even simpler if you use a framework. And the way that I'm using, I'm trying to do some routing is by using a regex. Again, not an optimal approach. This is very simple code. With a framework, you can use a proper router. But what I'm just saying here is, if you get a request, you can check if this request is of type /API/hotels/ some name, and I can use that particular name to check if I'm getting the same kind of request. So we parse the URL that we receive for every request. If it doesn't match our regular expression, we can assume that this is a 404 because this API only supports /API/hotels/some name. If it matches, we can extract the name of the city. And then we can call this helper function that we still need to write that says, okay, I need to await this helper function to give me hotels for this particular city. And then when we receive a response, we can just return it to the user. So at this point, everything is extremely simple. We are not doing anything special. We are just passing the URL, calling an asynchronous function to get the data, and then returning this data in a JSON format. Where the magic happens is actually in this function, get hotels for city. And this function, in the same file, we have a global object, which is a map that allows us to keep track of all the pending requests. So basically, every time we receive a call in this function, every time somebody is invoking this function, we can check, do we already have this operation pending? If we have it, we can just return the current pending operation. If we don't have it, we actually perform the query to the database, and then we store that this operation is pending. And we also have this bit of code which can be optional depending on how long you want to keep the information cached. Here, I'm keeping the information cached as long as the request is pending. You could keep it around, for instance, I don't know, 1 minute, 10 minutes, 20 minutes, 1 hour, whatever makes sense for you to keep going the data. So you can clean the cache in different ways if you want. Here, what I'm just saying is that as soon as that response is returned once, I'm just going to clean the cache. And finally, we return async operation. Now, there are a few interesting things here worth noticing. That when we do this query here, we are not using a wait because we don't want to block here. We don't want to stop the code there. We just want to capture that this asynchronous operation is happening and save it in the map and just return it to the user at the end. So if we go back to the previous code, basically what we are doing in line 15, this is where we are waiting. So the code that is sending a response to the user needs to wait for that promise to complete. But what happens if multiple users are making the same request is that they basically get the same representation of that operation because they get the same promise. So it's basically like different requests are awaiting for the same promise. So this is how we funnel out that result to multiple requests. And this is only possible, like creating this kind of patterns is only possible when you truly understand what are promises, what is async await doing, when you want to interact directly with promises, when do you want to use a wait, and when instead you just want to propagate promises. So when you do things concurrently rather than just waiting for the promise to settle. And if you do some tests, by the way, keep the test with a pinch of salt because the results will change a lot depending on the kind of traffic you get. But in this particular simulation, I think I was using 20 concurrent users, if I remember correctly. And the difference between a simple approach where we were doing 20 different queries and an approach where we do only one query to the database is that we get 90% more throughput, so 90% more requests per second. So you can see how these patterns can be very beneficial in terms of performance when you have applications with a lot of traffic and where that traffic is probably doing the same request over and over. So just to finish up, JavaScript can be very powerful and very convenient as a language, especially when you have applications that do a lot of input-output I/O operations. And this is very common when you do web servers, because web servers by nature are all request and response, calling databases, calling other APIs, and all of that stuff is asynchronous by nature. Now, the async story has evolved a lot. We started with callbacks, we ended up with promises, and finally with async await. So there are a lot of new ideas and patterns that emerged over time. And this is probably why, if you're starting JavaScript now, you can be a little bit overwhelmed and confused about all these things. But hopefully, now that you know the history and you know all the steps you need to do, all that story is easier to digest and make sense of it. And once you learn all the different steps, everything should be simpler and you have a lot of tools that you can use to achieve your goals. In my opinion, async await is probably the best solution in most cases because it gives you an easier mental model to write code, and generally people reading your code will be in a better position to understand what is the logic there. But to use async await correctly, you need to understand promises, and for promises, you need to understand callbacks. So again, don't skip any step, put the effort in, and learn callbacks, then promises, and then async await. And that's everything I have. Thank you very, very much for being with me. I don't know if we have any time for questions, so happy to try to take some of your questions now. If not, I'll be available on Twitter, LinkedIn, and whatever.
Sure, I think fine, folks. I think there was a lot of things that just got covered, right? there's a 30 seconds lag. I'll just keep waiting for your questions. If there are no questions coming up, no problem. There are 15 people on LinkedIn. I think please try to ask as many questions as you can, because it's very rare that you get people like Luciano in one stage and you just get the questions and answers. It gets up and running. So, all right, can you explain when we execute some code when hitting the endpoint on the server? What happens if we get multiple clicks on a particular endpoints at the same time? FYI, our await will take some time in getting resolved. I want to know if the request will be blocked or not. Thanks,
Okay.
Lucy. About
That's a good question. Well, before answering the question, I just forgot to mention that the slides are available already online. I don't know. I just dropped it here in the private chat. I don't know if you can
sure,
copy
sure.
them in the other chat. Thank you. So you can review all the code, and maybe some things will make more sense, because I realized I was kind of running over lots of content there. So to try to answer the question, so if I understand correctly, you are basically saying we have an endpoint. There are multiple users, or even the same users, that are hitting that endpoint multiple times. So what happens in the server, right? So, and I suppose you are referring to that particular request batching example we saw at the end. So what's going to happen there is that basically we do have multiple requests at the web server level, but we don't create multiple queries to the database. This is where we are trying to optimize. We are basically trying to optimize that layer that connects to the database. And what we really want to do is we want to create one single promise that represents that particular query to the database. And then for every new request that is trying to get the same data, we are basically associating the same promise. And when that promise completes, it means we completed the query to the database, we have the data. At that point, we have a bunch of await concurrently, because Node.js is still concurrent, is not blocking even if we use await. And all these awaits at that point will see, okay, this promise is now resolved, so I have the data and I can continue to the next slide. I don't know if you can put my slides again very quickly, because I think it's easier to understand if we look at the code.
sure.
Thank you. So basically, this await here, line 15, you can imagine that every new request will have an instance of this function running, and that function will stop here, waiting for that query to complete, and the query is done inside this other function. But all these instances of this callback here, this create server callback, are concurrent. So a single request here is not blocking every other request. A single request just creates a new instance of this function, and that single function stops here until the promise resolves. When the promise resolves, every single instance of this function will unblock, so to speak, and every user will go into line 17 and 18 and get a response in JSON. I hope that answers the question, but feel free to ask more clarifying questions if that's not the case.
Sure. I think it's already a past time. If you have any questions, don't worry, my friends. He will be available in any of the online platforms. You just have to just find him. That's it. He's in
Yeah.
Dev.to or AWS Bytes is there. Just go there, because AWS Bytes, I think probably there's a lot of insights that is coming up in the market, and I think that is what they're really converting. Yes, I think there is Vaibhav is very active. I think
Mhm.
design pattern is something which is complex. I think Luciano made a tough attempt in teaching you folks in a very short span of time. But it's all there. It's still learning. So however, I get the batching pattern. But what if we don't use the batching pattern? What happens to the other requests that are clicking at the same endpoint?
Yeah,
Right?
I guess it depends how you write your code, but the short answer is if we, at least the naive implementation that I did in that benchmark, and by the way, in that slide, there is a link where you can actually see the code. So there is a naive version that doesn't use batching and a version that uses batching. So you can compare the two pieces of code. In that naive version, what I was doing is just every single request is independent. So every single request will just call the database again, regardless. So nothing is still blocking. Like you still have multiple requests happening at the same time. This is actually the spirit of Node.js and JavaScript. The problem is that for every request, even if you end up doing the same query to the database, it is initializing a new query. So if you have thousands of users, you are basically creating a bottleneck because you are overloading the database with requests that are pretty much repeated. So it's not going to make a lot of difference in most use cases, at least. Like this use case where we are just fetching some data, that probably is not going to change very quickly. We are just doing that query over and over for no reason, while probably we could do it just once for all the concurrent users that are requesting the same data at the same time. Now, again, this is a very specific pattern. Like, don't focus too much on this pattern. It just wanted to be an example of when you understand async and promises, you can manipulate them in different ways to achieve different goals. If you don't really understand promises, you're probably just going to put a weight everywhere. And this is not always the right thing to do because you end up stopping at every step. Sometimes you don't need to stop. You can just do more things concurrently.
Sure, I think. Thank you so much, Luciano, for such great insights. Guys, don't worry, there is a lot. I am not even joking. Node.js might be just a combination of the V8 engine plus the C code, which is wrapped around, and it's now evolving over the course of time. But I'll say you one thing: Node.js is a very magical language. It's still JavaScript, but the way it compiles, the way it starts behaving, the way the load balancers have to be configured. You have to keep reconfiguring. If you are more of an Nginx person, you know the pain of reconfiguring, reconnection issues, this and that. I think there's a lot. We have to cover a lot. We have to understand a lot, and we don't have to just keep waiting. I think just go ahead, grab his book. Don't worry, he's still a social human being, and he just loves talking to as many people. All right. All right. I just wanted to end this, but okay, fine. If you are okay with it, you can just still go ahead and ask this question. I think Paul
Okay, I
is.
think this can be quick. Is it safe to use batching like that in prod? Is there a library? Good question. I don't know if there is a library. If it is safe, I will say technically yes. The only thing to be careful, as we know the joke, right? There are only two things that are complicated in IT: naming things and caching validation. So because this is effectively kind of doing a caching thing, this is only useful when we are really sure that users are requesting exactly the same data. So if you have, for instance, like a social network where somebody's saying, I don't know, give me the feed, but the feed is different for every user, right? This technique doesn't work anymore because you probably need to do different queries on the backend for different users. Even if it looks like the same operation, you still need to figure out exactly when is that same operation really the same. And then eventually you need to figure out when does the cache data expire and make sure it's cleaned up correctly. So it's hard to give you like a definitive answer, but in general, it is a safe technique. Just make sure that applies to the problem that you're trying to solve. It's not a technique that you can use everywhere and magically makes your web server faster.
Sure. I think, folks, I'm just ending the show because it's a very tough journey for answering something using Node.js. So let's just end this broadcast. Let's make sure that you guys learn a lot. And if you have any queries and questions, do reach out to Luciano. Thank you so much, folks. This is Vishwas Nayan signing off from the show. Thank you so much, folks.
Bye. Thank you for having me.
Sure.